Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for TWiT specials is provided by CacheFly at CACHEFLY.com. This is TWiT special number 30, a visit to the cave at the Ford Motor Company. Hi, Dan. Nice to meet you. Thank you for inviting us. You're a design engineer for Ford. Is that what you do?
Actually, I'm still considered a designer, considered a primary designer. I've worked my way into this new environment, which you're all going to experience here in a few minutes. So welcome to Ford, and let's get started. This is what we affectionately refer to as our black lab. It's a very large room that you'll see that's all been painted black.
What stage of development would this be? Is this a car in prototype? Is it something on the drawing board? Where are you typically?
What you'll see in the lab is we do a lot of upfront evaluations of program information, a lot of vision studies, for example.
So you'll ask consumers, you'll talk to people, and you'll say, how about if it were this? And then you create it in virtual reality?
Well, you know, a lot of those questions you might want to, you'll come up with new questions when you...
All right, okay, let's see. All right. This is PVC, the Product Visualization Center. Oh, boy.
So come on in.
Well, it is, ooh, oh. Hey, we are in a special secret spot now. There's stuff under this that nobody can see. Would you have been using AutoCAD in years past, or is this way beyond AutoCAD here?
Way beyond AutoCAD, yeah, definitely. Mostly CATIA, Viz Mockup.
And these are 3D virtualization kinds of things, or?
These are just CAD type softwares, and then we converted into ICIDO VDP software for the cave, and then I think, what is it, Autodesk?
Autodesk products, we use a lot of their stuff for the other environments, which we'll try to explain all those to you so you understand what we're doing here.
Awesome. It looks like somebody's been playing video games here. I don't know. Do you guys play video games all the time?
We can't say.
This looks like Need for Speed. I'm sorry. It really does.
Basically, we have 3 separate environments here in the lab, and I'll kind of break down, you know, what's the difference and the likenesses in all of them. But right off the bat, this particular area here is, we refer to this as the open volume because it's simply a big empty box, right? And we can put anything in here we want, whether it exists or not.
That's typically the phrase used in movies when they're doing green screen shooting. They call it the volume. So
exactly the same concept.
Similar.
Yes, we do exactly the same thing that they're doing in Hollywood. I'm not sure how much of this we want to capture on the cameras, but we use infrared camera systems around all of our environments, and they're common things that are, you know, bought off the shelf anywhere.
We've been asked not to show them, so we aren't going to shoot the cameras, but they're PTZ cameras with infrared pickups.
Anyone can get them. And then what we'll do with these is we're tracking infrared objects with them. We have these special markers, and it's like when you look at the green screen examples that you see on the web or on DVDs and stuff, they're all covered in these special markers. It's the same exact thing we're using here. We do it a little bit differently in that what you see on the green screens on the DVD features and things like that, what they will do is they will use the same type of camera capture system, and they will do their karate and all their whatever their, you know, the kind of stuff that they want to capture on film. And
they're doing motion capture.
They're doing motion capture, yes, that's correct. And then all those little markers, they connect them together and they become a skeleton. And then with that skeleton, then we can drop anything over the top of it, you know, like a cartoon, like Shrek, for example. So what we're doing in here differently than that is that we are calculating all that information in real time. We're not tracking the full body necessarily. We have the capability, but we don't have many customers for that need here. So we're tracking mostly your head and your hands, but we're doing it with live data. So we're not rendering it after the fact. We're putting you in there now, and we're showing
and watching what on a screen somewhere what it looks like.
We have that capability.
But are you putting humans in here? Who's in here?
We put anything we want in here. We can put, you know.
Is it a car? Is it humans? Is it humans in a car?
Yes, yes, yes. We can do all of that. Okay. This particular area right here, again, we call this the open volume, and we have certain types of studies where you could actually walk around a car and evaluate it without it ever existing. Wow. Or you could have a previous generation of a car, for example, and you could throw the new one over the top of it, and we can just and look at themes and things.
Would you now? Where is the output? Is it on a computer screen?
Well, in this lab, we don't typically output any data. We only help people to visualize.
Would I wear a helmet then? How would I see it?
We have a couple of different ways of visualizing the information. This one is typically done with an HMD, which is a head-mounted display, and we also use that in the second environment, which we'll get to in a moment. And you can see on the back wall is one example of a very unusual fixture, and we can bring in any type of unusual fixture to represent those hard points that you were trying to study, and then within your display you'll be looking at something that may be completely different or exactly the same depending on what you're looking for.
Wow, that's amazing. This is quite amazing. What typically are I guess there is no typical, but give me an example of some of the things they might test in here. What a brake pedal, how to reach it, things like that?
We do a lot of pedal reach studies, yes, but you'll see those in the next environment. And that funny fixture back there, this one was constructed for a reach study, so you can actually find out who can reach what kind of controls in different types of vehicles. And that configuration is set up for a tall truck, so we're looking at, the very large truck platforms in that example.
This must save a huge amount of money, because you can test something as expensive as this is. I'm sure it's a lot less expensive than building a prototype.
Absolutely true. In the next environment, we'll go ahead and move over there, and that will really drive that point home and what we're capable of doing.
That's great.
Again, we have the same type of motion capture system around this. And this big mechanical structure that you see in the middle has 51 live axes. So within the computer program, we can resize and reshape every one of these hard points in this thing to represent basically any vehicle made. We even have the capability, should we have the numbers, we could put competitors' vehicles in here as well. And this has been used for mechanical studies for a handful of years now. And Elizabeth, who unfortunately is not here to discuss this today, it was her idea to put this system around the top of it, where we are then able to drop our current geometry into this HMD, and then meanwhile you're sitting in a physical representation of that, wearing this head-mounted display.
I see the head-mounted display on the driver's seat right there.
That's our fixture where we do our calibrations for it, and we can immerse you too if you're interested. And then what you'll do is you'll be sitting in here feeling these touch points, but you're seeing the actual geometry.
Wow, that's pretty amazing.
Pretty good representations of what you could expect in the future.
And so this would be a good test of ergonomics for the most part.
Absolutely. Yeah. We do a lot of ergonomic type studies as well.
Yeah. And it's running Windows. Is it custom software that you guys wrote, or are you using off-the-shelf software for this?
Most of the stuff we use is off the shelf. The particular PVM thing, that is customized for the entire structure.
Because you were the only ones who got this. Yeah.
Everybody's got these.
Everybody does this now?
Everybody's got PVMs, but not everyone is using it the way we're using it.
Interesting. Okay. So this is something you have to do nowadays if you wanted to start Leo's car design firm. I'd have to have one of these.
That's right.
All right. Okay.
Now, in these particular computer screens, what you're going to see is these first two screens that I'm pointing at are the left and right eyes as seen through this head-mounted display in this PVM.
So this is actually, this is the PVM display. We're not seeing it in stereo because we've got two screens and we're
exactly.
not. Yeah.
This is exactly.
But it would be a stereo display in the headset.
That's correct.
Yeah.
Yes, that's exactly true.
And so I see it's an FX4.
Yep, this is an F-150, and we have this one set up so that we can, immerse you guys in it and see what it's all about.
Wow, that's so cool. That's so cool.
Next to this, we have an external display where we're kind of echoing this display so that other people on the large stereo display will now be able to understand what this person is seeing.
Observing the person. So they'd wear anamorphic glasses or some sort of glasses.
We use polarized glasses, and they work the same in all our environments. It's the same circular polarization. Not the same as an anaglyph.
It's different from anaglyph, yeah.
It is. It's a circular polarization. It's the same that we use in the cave and all our 3D stereo stuff. It's the same thing as your 3D movies.
Right.
Same exact glasses. Right. So everything carries over. It's a real inexpensive way for a large audience to have the same perception.
So you get a bunch of executives in here. You give them the 3D glasses, and they can look at these screens and see what the driver sitting in that seat is seeing.
Exactly.
Wow, that's cool. You can actually see. Is this a real city? I don't think so. It's a web city. But you can see the touch points here for the hands. Do they put on gloves when they're using this? Oh, he's going to go show us over here. You want to? Can we? Oh, there we are. Oh, there are. These are some special gloves.
Are the markers I was referring to previously? These reflective markers. This is a special. It's called retro-reflective tape, such that wherever they are oriented, this camera system can see them as a spherical marker. And this combination of markers in this configuration equals the left hand in this case. And so we can program.
You can see, in fact, the output right here. In fact, as soon as you moved it, it kind of got confused. They're going to go back in now. As he moves it in, there's his hands. Yep. Isn't that cool? As he moves them in. Wow, that's neat. That's really neat. He's going to get in now and show us how his head moves as the headset moves. So as you look up and down, your view changes up and down. Yeah, that's cool. That's really cool. What's the stoplight for up there? Is that just decoration, or do you actually use that for something?
Originally, it was intended to be used for something, but now we're able to represent things virtually much easier.
Yeah, you don't need a physical stoplight.
So now it's a nice decoration.
It's a prop. yeah, I like it.
Display. This is a state-of-the-art stereo display. We're some of the first people to use one of these that we're aware of.
These are real 3D. Real D.
Real 3D. So you guys
It's real D glasses. These are exactly the ones you'd. I don't think that'll work on the camera. These are exactly the glasses you'd wear in a lot of the 3D theaters. They use the real D technology. Oh yeah.
And if you step backward, you'll see that you
it converges at some point. Yeah. There you go. Now I've got 3D. Yeah. Wow, that's cool.
Even moving your head around, you'll see the 3D effect.
That's really cool. So typically you might have a gaggle of engineers standing here saying, "Touch the steering wheel."
Exactly.
What does that feel like?
Yeah, right. True. That's how.
This is the secret car. You may not look at that. Of course, no. I love it. In fact, it's more fun that you've got something under the wraps there. I love it.
Well, and this is the cave. This is not something special to Ford Motor Company. There are caves all over the world. This is new to us in this lab within the last 2 years or so, 3 years. Okay.
So this is really a simulator. Yes? No?
No, not a simulator.
It's a reviewing tool. It's a three-dimensional reviewing tool. You get inside the cave and you're immersed in three-dimensional data. We'll put in CAD data that will give representations of what our vehicles are. It's the actual CAD data that we do the builds from.
So this is what I see if I look out the window. This is the line of sight. This is where a rear view mirror is, that kind of thing.
What your field of vision would be out through the glass.
My wife complains on her Toyota because the side mirrors block a pedestrian crossing the street. You would have caught that.
And we have been catching that. That's one of the main focuses we've been working on the last couple of months on several of our vehicles. So.
And this is a great way to do it.
Yes, it is. It's used all the way to upper management's been in here many times, and a lot of cost savings decisions have been made in here that saved us a lot of money and time.
So it's also a stereo display, I can see, and we have the 3D glasses and everything.
Yeah, and we're tracking your head movements in this. So the person who is seated in this environment will be wearing the head tracking glasses. So
he's got the dots on his glasses. Yeah,
that's correct. And then other participants will be able to watch from out here, but you don't get the accurate perspective of what they see. Hence the echo monitor we have over here. So.
He says the cameras inside are tracking his glasses. That's what those dots are on the glasses. So as he turns his head, it moves around. He's in a flex right now, and that's pretty amazing. That's pretty amazing.
With the types of evaluations that we do in here, we have pretty much eliminated certain levels of prototypes that we used to have to build in the past. Like in the PVM, for example, we can We can have parts cut out of foam or plastic or wood or anything that they would want to make it out of real quickly and easily, and we can put them into that environment as physical touch points and then throw this geometry right over the top of it so we get accurate one-to-one representation of what their thinking might be at that point.
You still, I mean, they still make clay carvings of the body and they put them in the wind tunnel. There's still a lot of those steps are still there, but at the very early stages you can catch gaffes before you actually get to the stage where you're starting to manufacture things.
Absolutely true. Before you cut any hard tools, we can do a lot of evaluations in this lab where you're going to be building a tool that would make sense instead of retooling a few months down the road.
Really cool. Looks like, where are you? It looks like you're in France there. Germany, okay. Any reason for Germany? Just that's what the software did? It was available. Doesn't really matter, does it? It could be anything out the window. That's great. How cool. How fun. Well, it's really neat to see all the stuff that you're doing here. It's very exciting. I thank you for...
Good place to work. We got a great team here, and we're accomplishing a lot. We're pretty excited about what's...
Thanks for your time. I'm sorry we interrupted your lunch. But you can get back to lunch. Thank you. Wow, what a great facility. Thank you so much for your time and giving us this little tour. I think we're at the end of our day, are we not? Scott, come on here. I just want to thank you, Scott Monty, for letting us do all this. This was incredible.
We are so glad you came out here to actually see what we do here, and there's so much more for you to see, so you're welcome back anytime. Really.
Oh, yeah. Well, we'd like to come back. It's obvious things are always happening here at Ford.
Yeah, always exciting innovations, and if there's anything fans want to see, let us know, and we'll see if we can make it happen.
What's your Twitter handle?
Scott Monty, or Ford.
It's short, sweet, easy to remember, and Monty's M-O-T...
M-O-N-T-Y.
M-O-N-T-Y.
Like the full Monty.
It's like the full Monty. Hey, thank you all for being here. I hope you've enjoyed this live tour. As I said, we're going to take it. We're going to make it a special. You can download it in a couple of days, probably Tuesday of next week, from the TWiT Live Specials, twit.tv/specials. And we will rerun this a few times during the day so you can see it. I think we've got to get to This Week in Law is coming up pretty soon, so we're gonna get to that. We do thank you. Thanks again to Brent. What's your last name?
Bye.
Brent Mai? Bye. Brent Bye. B-Y-E. Perfectly named for this final segment, for handling the cameras and surviving in the back seat of that. Well, actually, you survived two incidents. Me parking the Flex, and I don't know which was worse. And then going around the test track in that Shelby. That was amazing. Also to Ken Shepherdson, our Director of Engineering, who's carrying the pack today. Better him than me. Our producer, Lisa Kensel, who's been working very hard and following the chat room. And everybody at Ford for letting us come out here. Boy, this was really, really a great time. Tomorrow we stay live in Dearborn. We're going to go to the Henry Ford Museum and Greenfield Village for Maker Faire. We'll broadcast live from there. In fact, there'll be some good... I think Prasad's going to join us. We're going to get a demo. What's he going to show us?
Well, he and Mark Hatch, the CEO of Tech Shop, are going to talk about the new DIY, do-it-yourselfer shop that we've got here in Detroit to help people who are tinkering with all sorts of things, including automobiles, to actually bring it to life.
A great way to get innovation happening and maybe perhaps putting it into the next generation of Ford vehicles. That's very exciting. So we'll see you tomorrow. We're going to start again at 11 a.m. Eastern time, go to 2 p.m. Eastern time. That's, I guess, 8 to 11 Pacific time. And then if I add my numbers right, it's 1500 UTC. We'll be broadcasting right here live.twit.tv from the Henry Ford Museum and Maker Faire in Detroit. So thank you for being here with us. And we'll sign off now, take you back to your regular scheduled programming on twit.tv. Leo Laporte, we'll see you next time. Bye-bye. Thanks, Scott. Really great. Really great. Really a lot of fun. Hey, so I thought we're going to say goodbye. I know you're ready to sign off, and we're going to go into reruns. But before we do, I wanted everybody to say hi. So we're going to go down the line here, and you don't have to walk backwards. We're just going to say hi to everybody. Hey, everybody. Hi, Michigan. Thank you for coming out. Mary, best cupcakes in the world. Oh, my God. Nice to see you. Hey, guys. All right, we're gonna move fast here. We're going by. Just give me, no shake, just a high five. All right. And then we're going to, all right. right, I'm going to go backwards. Look at this. Oh, don't let me run into anybody. Oh, she's cute. Hey, oh, I'm sorry. Hey, how you doing? Good to see you. I'll be back. We're going to move fast in the line. Say goodbye to everybody at the TWiT Cottage. We're saying goodnight for the night. We're going into reruns. Say goodbye to the TWiT Cottage. All right. There's a lot of geeks in the world. It's kind of amazing, isn't it? Nice to see you again. How you doing? How you doing, guys? How'd you get that? Oh, it's a cover. Okay, good. I like it. I just, I spot a few things in the audience. Hi, how are you? We'll be back in just a bit, okay? I'm just going to say goodbye to everybody. Oh, my God, there's a whole lot of you. Holy cow. Oh, my goodness. I'm saying hi to myself. That's creepy. All right, keep moving here. Well, there's more of you? Oh, my gosh. We're moving as fast as we can. We're just saying goodbye. We're closing it down to the TWiT Cottage, but I'm not leaving. Don't worry. We're just, oh, my gosh. Oh, my gosh. There's sure a lot of you. Wow. And finally, the last guy in the line.
Hey, Leo.
Thank you. Michigan rocks. We've had such a great time here. Don't forget to tune in tomorrow. We're going to be at the Maker Faire. We're going to have a great time. We start our broadcast at 11 a.m. Eastern Time. That's 8 a.m. Pacific Time, 1500 UTC, live.twit.tv. Thanks to everybody. I think that the Hyatt Dearborn did not expect this. I know we didn't. We're really very grateful. Thank you, everybody. Thank you, Michigan. We'll see you tomorrow live from the Maker Faire. Back to Current Geek Weekly. Good night.
Doing the TWiT.